Hello, it's Mrs. Fike again, here to talk about acid and base definitions. In Unit 10, objective number 2 is define and recognize Arrhenius and Bronsted-Lowry acids and bases. These are the two acid-base definitions that we will be discussing. First, the Arrhenius definition. Arrhenius acids produce hydrogen ions, or H+, when dissolved in water. You can see several examples here. All of the chemical formulas, if you'll notice, have hydrogen. That's the source of the hydrogen ions, or H+, when the acid is dissolved in water. All of the diagrams have the hydrogen represented with a white dot. You can also see the hydrogen here, here, and here. And then notice the names of these substances. We have hypochlorous acid, nitric acid, and this one is called hydrogen iodide, but we also call it hydroiodic acid. So they all have acid in the name. Arrhenius bases produce hydroxide ions when dissolved in water. Hydroxide is OH with a -1 charge. So here we have sodium hydroxide. It makes sodium ions and hydroxide ions. And potassium hydroxide makes potassium ions and again hydroxide ions. And in the diagram, that's sodium hydroxide. You can see the sodiums are represented with the gray dots. And then the hydroxide is oxygen and hydrogen bonded together with the -1 charge. That's the red and the white dot together. This definition is very simple. You do have to put the acid or the base in water to produce the ions, the hydrogen ions or the hydroxide ions. But there is one other definition that we can use that will include more substances, and you don't necessarily need water. That definition is the Bronsted-Lowry definition. We don't need the water, but we can have water. But in this definition, we do get to include more substances. And in this definition, we get to focus solely on the movement of the hydrogen ions, H+, or we also can call them protons. We are not looking at hydroxide, OH- at all. So what makes something a Bronsted-Lowry acid and a Bronsted-Lowry base? It has to do with the hydrogen ions, the H+, and acids will donate, bases will accept. So you can see in the diagram below, the hydrogens are again represented with the little white dots. And the hydrogen moves from here over to here. So this substance is the acid because it has lost or donated the hydrogen. And then that makes the other substance the base because it has taken or accepted a hydrogen ion or proton. In the Bronsted-Lowry definition, we will always be looking at chemical reactions like this, and one reactant will be the acid and one reactant will be the base. And then you can also see on the product side what everything has kind of turned into. The white dot that was lost from here just leaves the green dot over here. And then the white dot that was gained here, you can see, is included on the product side. So let's look at a couple more chemical equations to see if we can identify the Bronsted-Lowry acid and the Bronsted-Lowry base. The easiest way to do this is to pick one reactant and try to find the product that it turns into. Then you can see if it has gained or accepted a hydrogen, or lost or donated a hydrogen. So if I choose this ammonia, I can see on the product side it turns into NH4 plus. So it goes from 3 hydrogens to 4 hydrogens. So that means that it has accepted an H plus hydrogen ion or proton. That makes ammonia the base. Now, if ammonia is the base, the water has to be the acid, but let's just follow it. It would have to turn into the OH minus, the hydroxide, and you can see it's gone from 2 hydrogens to just 1 hydrogen, so it's lost or donated. That makes it the acid. So ammonia is the base and water is the acid. Notice we do have water in this equation. We don't have to, but in this case we do. In the next example, HCl turns into Cl. It has lost or donated a hydrogen ion or proton. That makes it the acid. You maybe recognize this chemical formula as hydrochloric acid, and therefore the definition of acid should make sense here. That makes water the base. We'll always have one acid and one base. And you can also see that H2O became H3O plus, going from 2 hydrogens to 3, and that makes the water an acceptor. It has gained a hydrogen. So something interesting about water here, notice in the first example, water was our acid, and in the second example, water was our base. Substances that can act as acids or bases are called amphoteric. Just a little FYI. So hopefully now you know how to define and recognize Arrhenius and Bronsted-Lowry acids and bases. Please complete this short 3-question quiz before class tomorrow.